So we want to evaluate the double integral over this region R of x minus 2y over 3x minus y dA. But this time R is going to be a parallelogram bounded by those four lines. So let's take a look at our region and determine how best to proceed. So what do we have here? We've got this parallelogram, and we recognize that the southern boundary changes as we move along. Here the southern boundary is blue. Here the southern boundary is purple. So let's have a conversation how that's going to work. So breaking this up, we can see we would go blue to green on this range of orange values until about 0.4. Then we go from blue to red on this range of orange values, which is from 0.4 to 2.4. Then we go from this purple line to this one on the remainder. So that would require three separate double integrals, but there might be an easier strategy for us. We're going to change variables and make use of the Jacobian. So we're going to define some new variables here. We're going to say u equals x minus 2y. And if that's the case, we can see u ranges from 0 to 4. And we can say v equals 3x minus 1. Excuse me, 3x minus y. And v ranges from 1 to 8. Now, do we recall what the Jacobian was? It was built out of partial derivatives. And the Jacobian was the determinant of what? The partial of x with respect to u in this slot. Partial of x with respect to v here. Partial of y with respect to u. Partial of y with respect to v. So this is the information that I need, but I'm going to need to do a little bit of algebra before I can get there. So we have u and v, and my goal is to eliminate the x's. So let's go with negative 3 times u and v and see what happens. And we can see that the x's subtract out, and then I have negative 3u plus v equals 6y minus y equals 5y. Dividing by 5, we get negative 3/5 u plus 1/5 of v equals y. And now getting y with respect to u, y with respect to v will be relatively easy. To eliminate the y's, I'm going to multiply v by negative 2. It becomes u minus 2v. You'll notice the y's subtract out. 1x minus 6x is negative 5x. And then dividing by negative 5, that will give me negative 1 over 5u plus 2 over 5v equals x. So collecting our information, there's our original integral. There's the formula for the Jacobian. Our definition of u and v. U ranges from 0 to 4. V ranges from 1 to 8. We showed with algebra that x was negative 1/5 u plus 2/5 v, and y was negative 3/5 u plus 1/5 v. So let's go ahead and find those partial derivatives. Partial of x with respect to u is negative 1/5. Partial of x with respect to v is 2/5. Partial of y with respect to u is negative 3/5. Partial of y with respect to v is 1/5. So let's lay out our elements in our determinant for the Jacobian. Determinant of partial of x with respect to u, negative 1/5. Partial of x with respect to v, 2/5. Partial of y with respect to u, negative 3/5. Partial of y with respect to v, 1/5, which will be negative 1/5 times 1/5 negative 1/25 minus negative 3/5 times 2/5 negative 6/25, which is negative 1 plus 6 or 5/25, which equals 1/5. So our Jacobian gives us 1/5. Now remember that dy dx or dA, which is dy dx, is the absolute value of Jacobian du dv. So that will give us 1/5 du dv as we go from there. So let's continue our computation. So looking at our double integral, x minus 2y is u, 3x minus y is v. dA we said was what? We said it was the Jacobian times du dv. The Jacobian was 1/5. du dv. So we could go du dv or we could go dv du. It doesn't really matter. What does u range from here? U ranges from 0 to 4. And v ranges from 1 to 8. So this should enable us to evaluate that integral. We'll pull out the constant of 1/5 first. So we have 1/5 integral as v goes from 1 to 8, as u goes from 0 to 4 of u over v du dv. So let's focus on the inner integral. The integral is the integral as u goes from 0 to 4 of u over v du. Now, as far as u is concerned, v is a constant. So 1 over v can come out in front of that for my inner integral. So you have 1 over v times the integral as u goes from 0 to 4 of u du, which is 1 over v times u squared over 2 as u goes from 0 to 4, which is 1 over v4 squared, 16 over 2, minus 0 squared over 2. 8 minus 0 is 8. My inner integral is 8 over v. So we'll substitute 8 over v in here for that inner integral and see what we get. So our inner integral is 8 over v. You see the substitution. 8 is perceived as a constant. That can come out in front. So I get 8 times 1/5. 8/5 integral as v goes from 1 to 8 of 1 over v dv, which is 8/5 natural log absolute value of v as v goes from 1 to 8, which is 8/5 log 8 minus log 1, but log 1 is just 0. So my final answer will be 8/5 of the natural log of 8.